trains leave a city at the same time. One is traveling east. Think about going towards Atlanta. The other one is traveling west. Okay, so think about going towards Mississippi, like Starkville, Mississippi. I think that's where Mississippi State is. Okay? At the end of 9.5 hours, they are 1,292 miles apart. If the rate, that's your speed, of the train traveling east is 8 miles per hour faster than the other train, find their rates. So we're trying to find the rate of the train going towards Atlanta and the rate of the train going towards Starkville. Okay, so we really need to get a picture in our mind about what's going on. Okay, and I will tell you, this word problem is as bad as it gets. I would almost say this word problem is as bad as it gets in the whole class. But that might not be 100% true. But this word problem is as bad as it gets right now. And then we won't be doing word problems for a while. Okay, so let's think about what's happening here. Here we are in Birmingham, Alabama. Here we are in Birmingham. My train that's going east is heading towards Atlanta. My train that's going west is heading towards Mississippi. Okay, at the end of 9.5 hours, how far apart are the two trains? Good, 1,292, 1,900 or 1,292. Okay, so the distance from wherever the train heading west is to the distance wherever the train heading east is, and I think the one heading, east may be in the Atlantic by then, is a total of 12,092 miles. That's a total of how far they are apart. Now, neither one of them are 1,292 miles from Birmingham. That's how far they are apart. Okay? Now, how many hours did the train going to Atlanta travel? How many hours? Good. My train going to Atlanta traveled 9.5 hours. How long did the train heading to Starkville travel? 9.5 hours. Okay, so they both traveled the same amount of time. Now, that's where you start. I haven't done anything with rate. I haven't done anything algebraic. All I've done is kind of draw a picture to wrap my mind around what is happening. Okay? At least do that. I give a point for drawing a rectangle on word problems. Okay? So definitely get started. Do something. And what I tell students to do is to come back to it. Okay? Every time you get stuck, come back to it. Okay? Read it. Go do another couple problems. Look at those word problems first as soon as you get your test or your quiz. And then come back to them. Okay? So I've just drawn a picture. So what I'm looking for is how fast each of the trains are going. So we're going to key in on this statement right here. If the rate of speed of the train traveling east is 8 miles per hour faster than the other train, find their rates. So rates are our unknown. We don't know how fast either one's going, but we do have a relationship between the two rates. If my train that's heading towards Starkville is going R miles per hour, how fast is my train heading towards Atlanta? It's not just 8. It's R plus 8. Good. And that's because it says if the rate or the speed of the train traveling east is 8 miles per hour faster than the other train, find the rates. Okay. So now we actually have enough information to figure this out. A very popular and well-used formula is distance divided by time equals what? It does equal rate. Okay, so if I travel 120 miles and it took me 2 hours, how fast was I going? If I travel 120 miles and it took me 2 hours, I traveled at 60 miles per hour. So distance divided by time equals rate. Now, a very close cousin of this formula, if I multiply t times both sides, I end up with distance equals rate times time. And that's the formula that we're going to use to solve this. I will give you both formulas on the test. I'll give you both formulas on the test.
But for this one, it's the second one?
We are. Yeah, we're using the second one. Distance equals rate times time. So, if I know that my train heading to Starkville travels at a rate of speed, r, and I multiply that times 9 1/2 hours, what does that represent? So I've got a rate times a time. So what does this represent about this train? You got it. You guys that aren't sure, say it a little louder. Distance. Good. You got it. Okay? This right here represents the distance that this train traveled. How do I represent the distance this train traveled? Okay, so r, and you're very close. It's r plus 8 times 9 1/2. Okay, because r plus 8 is the rate of that other train. Now, if I take the distance that this train traveled and I add it to the distance that this train traveled, what's my total distance? 1,292 miles. So now we have our formula. Okay, now I'm going to clean it up a little bit so that we can solve it. Okay, I have 9 1/2 times r plus 9 1/2 times r plus 8 equals 1,292. Okay? Now I'm going to go to the next slide and solve this. So this is a decent picture to take. Okay? Okay. So I have 9 1/2 times r plus 9 1/2 times r plus 8 equals 1,292. Okay, I'm going to change 9 1/2 to an improper fraction. Okay, 2 times 9 is 18. 18 plus 1 is what? Good. So I have 19 over 2 times r. Okay, 9 1/2 is 19 over 2 times r plus 8. I'm going to go ahead and distribute that 19 over 2 because it works out pretty nicely. The 19 is 9 1/2 as an improper fraction. So 19 over 2 and 9 1/2 are equal. Good question. Okay, so I've got 19 over 2 r plus 19 over 2 r. I'm distributing. Then I have 19 over 2 times 8 over 1. And that simplifies very nicely. 2 goes into 2 one time. 2 goes into 8 how many times? 4. Good. Good, good, good. 19 over 2r plus 19 over 2r equals 19 times 4. Sorry, that's plus 19 times 4. And that equals 1,292. Now, At this point, you may decide to multiply everything by 2, and that's reasonable, and that's totally fine, and there's no problem with you doing that. However, when we add 19.2r plus 19.2r together, it takes care of itself. Okay, we've already got a common denominator. We're like in great shape as far as fractions are concerned. So 19 plus 19 is 38 over 2r. What's 38 over 2? 38 over 2. It's 19. Okay? So when I add those two together, I get 38 over 2. And that simplifies to 19. Okay. And we know how to do this, right? I subtract 76 from both sides. I get 19r equals 1216. Okay? And my final step is to divide both by 19. And my final answer is 64 miles per hour. Okay. Now, I want us to go back to the picture. Okay? So I want to go back to the picture. Which one of these trains is going 64 miles per hour? The westbound one. Okay? So the westbound train is going 64 miles per hour. So how fast is the eastbound train going? Excellent. Excellent. So this is my final answer right here. Okay? That's as bad as it gets for word problems. I promise. Okay? You ready for the next one? You're going to love the next one. You're going to be like, sweet. Okay, I'm going to the next one. Okay, Della. Della bought a dress at a 20% discount for $57.60. What was the original price? Now, if you make a mistake with this one, you're making a mistake with your thinking. You're making a mistake with your thinking on how much Della spent for this dress. $57.60 was a sale price. Okay? She bought it at a discount for $57.60. Okay? So this is a sale price. That's my sale price. Okay? 20% is how much off. So she got a discount of 20%. Now, two things that I want you to think about. Is my original price more than the sale price or less than the sale price? It would be more, okay? So she found this dress she loved. She had a 20% off coupon. So if the dress was listed at $100, how much did she pay for the dress? $80. Excellent. $80. That's exactly what she did. Now she didn't pay $80 for the dress. So this is where students make mistakes. Right here. If 20% was the discount, that's how much she took off, what percent of the dress did she pay for? If 20% is how much she got off, what percent did she pay for? Excellent, 80%. That's the thought, that's the jump that you've got to do. And that jump is where students make their mistakes. So she's paying 80% of the original price. Okay, and when she paid 80% of the original price, what was it? What was the price she paid? Excellent. Okay, now, all we got to do is write this in an equation now. How do I write 80% as a fraction? I mean, not a fraction, a decimal.
0.8.
Good. And I'm going to go ahead and write that as 0.80 because it'll make a little bit more sense in just a second. And if I multiply 0.8 times my original price, I'm going to get $57.60. Okay? So don't hesitate to write that out as 80% of original price equals $57.60. Now, do we know how to get rid of our decimals? What do I multiply this by to get rid of my decimal? Okay, I actually don't have to multiply it by 1,000. I just have to multiply it by 100 because I've got 2 spots here and 2 spots here. So I multiply it by 100. So then I get 80x equals 5760. Okay? 80 divided into 5760. Okay, I'm going to mark out a 0 because I can. 8 goes into 57 7 times. 7 times 8 is 56. 8 goes into 16 twice. How much was her dress? $72. So she got a $72 dress for $57.60. Yes?
So, like, if we get a question like this on a test, do we have to write out the equations and stuff like that? Because I just did 5760 divided by 0.8, because I know that, like, for example...
That's an equation for me.
Okay.
Yeah, you're good. Okay. Now we're going to go to geometry. This is where I get my rectangle thing all the time. Go ahead and take a picture. Suppose the length of a rectangle is 2 meters less than 4 times its width. Suppose the length of a rectangle is 2 meters less than 4 times its width. The perimeter of the rectangle is 56 meters. Find the length and width of the rectangle. Okay? Now when you look at this, you're probably looking at it like, oh, I don't want to do a word problem. Okay? What is the one thing that you can pull out of this without a lot of effort? What kind of shape am I talking about? A rectangle. Draw a rectangle. Okay? The first time you read this, you may look at that and be like, I've got no clue what to do. Oh, there's the word rectangle. I'm going to draw a rectangle. Okay? So the first time you look at this, draw the rectangle. Say, okay, Alicia said she'd give me a point for a rectangle. There's my point. Okay? Now, read that. We're going to read that last sentence again because there's not a lot of algebra-y stuff in there. The perimeter of the rectangle is 56 meters. Find the length and width of the rectangle. Okay? Perimeter means that if I take this side and add it to this side and add it to this side and add it to this side, what will I have? 56. So I will give you formulas. And the formula for perimeter is 2L plus 2W equals P. Do we know what P is? 56. So we got 2L plus 2W equals 56. Okay, so we're getting closer. We're like, okay, we're getting closer. This isn't terrible. Okay, now I'm going to focus on that first part of the sentence. Suppose the length of a rectangle is 2 meters less. 2 meters less. How do I write 2 meters less? It's not 2 minus. Yes?
Is it 2 less than?
No, so think about your operations. Subtraction, addition, multiplication, and division. So how would I write 2 meters less than? Minus 2. Yeah, okay, minus 2. So this is 2 meters less than. So we're going to have minus 2. Okay, then 4 times its width. How do I write 4 times its width? 4W. Okay, and you may have put 4X or something like that. Because we're talking about perimeter, I'm going to go ahead and do 4W. So that right there is the difficult part. Getting that 4W minus 2. That's the tough part. Once you've got that, you're golden. Now, another place that students sometimes get confused and they sometimes struggle is, well, what's the length of that other side? So I've got one of the sides, but Alicia, I've got to have the other side. And it's one of those things that's kind of right in front of us, but we still miss it. Okay, so it says, suppose the length of a rectangle is 2 meters less than 4 times its width. So what is the length of that other side? W. Good. Okay, so this is W right here. And now I've got it. I can plug this stuff in. So I've got 2 times 4W minus 2 plus 2W equals 56. 2 times 4W is 8W. 2 times negative 4. 2 times negative 2 is negative 4. Okay. I'm going to add the 2W and the 8W. Okay. Now I'm going to add 4 to both sides. I'm sorry, guys. I'm going right up here. So I get 10W equals what? 60. 10W equals 60. So what does W equal? 6. Okay, W equals 6. And we're talking about meters, so 6 meters. If W is 6, what's the length? If W is 6, what's the length? 22. 22. 4 times 6 is 24 minus 2 is 22. Okay? So write those down piece by piece. Okay? If you break it apart piece by piece. Okay? Okay, now we're going to talk about Rex. Okay? Whoops, I guess I didn't erase Rex's homework. Okay, Rex. Rex is in an algebra class. Okay? Rex has scores of 85, 92, 87, 88, and 91 on his first 5 exams. What score must he get on the 6th exam to have a 90 or better for all 6 exams? Okay? So, he's taking a class. It's towards the end of the semester. Those are his exam scores. Okay? He doesn't want to know what his average is right now. He wants his average to be 90 or higher at the end, but he's still got this missing test. So we have to figure out, what does he have to score on this missing test? Okay? That's what we're figuring out. We have to figure out what he's got to score on a test that he has not taken yet. So the score is unknown. So what we're going to do first is we are going to start with these exams. If I said to you, how do I find his average right now? How do I find his average right now?
You add them all and divide by 5.
Good. I add them all and I divide by 5. Why 5?
That's the number of exams he has right now.
Good. That's the number of exams he has right now. So if I wanted to find out his grade or his average right now, I would add all of these up and divide by 5. That gives me his average right now. Excuse me?
He only has 4 exams.
He does have 5. It's written down a little lower. Do you see the 91? Yeah, it is at an awkward place. I agree. Okay? But if he only had 4, then you would divide by 4. Okay? Now, but we don't want to know what his average is right now. What do we want to know? that sixth test. We want to know what has to happen on that sixth test. So he hasn't taken that sixth test yet, but how can we represent that sixth test? X or T or A, because he wants to get an A on it. Okay. Now how many do we divide by? 6. Okay. That 6 right there is where students miss it. They only want to divide by 5. You want to divide by 6 because that's how many tests you will have taken at that point. Okay? Now, this has got to be greater than or equal to 90. Now, we know how to solve this. The first thing that we're going to do is we're going to get rid of that 6. We want to get rid of the 6 by multiplying both sides by 6. These 6's cancel. And on the other side, I get 540 because I have multiplied both sides by 6. My next step is to add up 85 plus 92 plus 87 plus 88 plus 91. I'm going to add all those up. And when I do, I get 443 plus X. Okay, so we're trying to find out what this X is. What's my last step? We know how to solve this. What do I do now? Good. Good. You're exactly right. So I subtract both sides. So X has to be greater than or equal to 97. So he needs to score 97 or higher on his last exam. That's what he has to score on his last exam. Okay. Problem solving will not be on your quiz on Friday. It will be on your test the following Thursday. Okay? So be sure you take a look at that. Your quiz is a small group quiz. I'll put you in groups and you can kind of talk through it. Yes, ma'am.
I know you're the teacher and I don't mean to correct you, but it's 453 and not 443.
Yeah, no, you can always correct me.
Okay.
What is 453?
The 400.
Got it. Oh, I gotcha. No, I want you to correct me if I'm wrong. This is what happens when I start moving too fast. Are you sure?
Mm-hmm.
14, 22, 23. I am still getting 443.
Oh shit, then maybe I did it.
That's okay.
I was like, that was a bold move to correct her.
No, you're fine. I don't mind at all. I just want to make sure that when I correct it that we're both right. There we go. Okay, so 443. You're totally fine. Please don't worry about it. Please don't worry about it. Okay? Okay. So let's go. We're going back to inequalities. So we're switching gears. And I said that I was going to do this inequality in the help session, and then I forgot. So we're going to do it here. So it's just a little bit more intense. It's definitely a more intense inequality. So we're going to solve it, we're going to graph it, and then we're going to write the answer in interval notation. The first thing that I need to do here is distribute. Okay? So I'm going to distribute. 3 times 2x is 6x. 3 times 1 is 3. Now, do you see that negative 2 right there? We forget to distribute that negative to both. Students typically do okay distributing the 2, but they forget about the negative. Okay? So I've got negative 2 times 2 is negative 4x. Negative 2 times 5 is negative 10. That's where students make mistakes, right there, that negative 10. Sometimes they make it positive 10, and that's incorrect. We have to distribute that negative. Okay, and then we have less than 5 times 3x is 15x. 5 times negative 2 is negative 10. Okay, now it's a little bit less intimidating. So the next thing that I do is I combine like terms. I have 6x and I have negative 4x. So I have 2x. Then I have 3 and negative 10. Much more manageable. We're dealing with things that are much more manageable now. Now, when we are dealing with inequalities, I always like you to move to the left. Move that variable to the left. The reason is it makes graphing it significantly easier. Significantly easier. So I'm going to subtract 15x from both sides. Okay? I'm going to get negative 13x minus 7 is less than negative 10. I add 7 to both sides. Okay, and I'm left with negative 13x is less than negative 3. And that's an icky fraction. So we're going to get an icky fraction. So now I'm going to divide both sides by negative 13. When I divide by negative 13, two things happen. Two things happen. The first thing we're going to look at is right here. Negative 3 divided by negative 13. What does that give me? Negative divided by negative. Positive. Okay, so that becomes 3 over 13. What happens here? What do I have to do? I've got to flip it. Okay, so whenever I divide both sides by a negative, I have to reverse the inequality sign. I have to reverse the inequality sign. Okay? So don't forget that. Here's my 0. 3 over 13 is a pretty small number. It's positive, but it's pretty small. Where is it going to go on my number line? Yeah, between 0 and 1 and closer to what? 0. And it's greater than, right? Okay. Now we've got our graph. Oh, it should not be. It's just a parentheses. There we go. So it should be a parenthesis. So my final answer here is parenthesis 3 over 13 to positive infinity. Okay? Yes?
Why does it have to be a parentheses instead of open?
Okay, that's a great question. Why is it parenthesis instead of an open dot?
Yeah.
On the graph, it could be an open dot. It's fine for it to be an open dot on the graph. The graph is to help you write it in interval notation. And so as long as you associate the open dot with parenthesis, you're fine. But it does have to be a parenthesis for interval notation. Good question.
So when do you use an open dot?
I'm sorry?
When do you use an open dot?
We typically don't in this class use an open dot. Open dot is kind of what we did middle school and early high school. We used the open dot before interval notation was introduced.
Just like it's in my notes somewhere else. So I was just didn't know if there's like a time when you use it and a time when you don't.
You do use it during piecewise functions and when you have holes in graphs and calculus. But for this class, I would just use the parentheses. Okay? Okay. So now we're going to take a little bit of a jump. And we are going to do compound inequalities. This is another reasonable screen to take a picture of. This is another reasonable screen to take a picture of. Okay? And don't forget, this is all being recorded too. Compound inequalities are when we have two inequalities combined with the word and or. So I want everybody to kind of look at what you've got on. Do you have on jeans? Do you have on a hoodie? Do you have on a sweater? I always dream of wearing my yoga pants to work, but they tell me I can't. But anyway, if you have on jeans or a hoodie, I want you to stand up. If you have on jeans or a hoodie, stand up.
What about both?
Jeans or a hoodie. I know. Okay. Yeah, that's a hoodie. Yeah. This is not like real scientific. I'm just going to illustrate a point. Okay, so everybody standing up has on jeans or a hoodie. Okay? Now, if you have on jeans and a hoodie, I want you to stay standing. Everybody else sit down. If you have on jeans and a hoodie, see? Drastically reduced because they had to meet both criteria. Okay? Or we had a whole bunch more. Thank you very much for standing up. Okay. So now we're talking about compound inequalities, and we're taking that idea. When we say the word and, both criteria must be met. Both criteria must be met. When we put that into interval notation, my answer looks a lot like an ordered pair. Okay? It looks a lot like an ordered pair. Okay? It's not an ordered pair. It looks like an ordered pair when I have the word and. When I have the word or, it's either criteria can be met. So in our example, you could have on jeans or you could have on a hoodie. And that's when you stood up. Either criteria can be met. Your answer typically looks like two interval notations combined with the U sign. That U sign means or. The U sign means or. Okay? Did everybody get a picture of this that wants a picture of this? Okay. So now we're going to start by just graphing these ors. We're just going to graph these ors. Okay? So what we do is we graph both on same number line. Okay? We graph both on the same number line. Okay? If 0 is right here, here's my 0, I'm going to graph x is less than negative 1. I'm going to graph x is less than negative 1. So at negative 1, I'm going to have a parentheses. And I'm going less than, so I'm going towards negative infinity because it's less than. Okay? Now I'm going to graph x is greater than 2. X is greater than 2. I'm going to have a parentheses at 2, and I'm going to go towards positive infinity. That's my graph. Now I want to put it in interval notation, and I look at my graph to do that. What number is way down here? Good. And your interval notation always goes in line of the number line from left to right. So I have negative infinity, and I go all the way to negative 1. What sign means or? U. Then I start again with 2, and I go all the way to positive infinity. Okay? That's what a graph of an or statement typically looks like. Typically, it looks like this. Okay? And you typically have 2 different points. Or is the key word. Okay? Yes?
So the interval notation is the parentheses or the one at the top?
The interval notation is this right here. This is what your answer has to be in. And that's used in mathematically a lot. Okay. Now we're going to do and. Now we're going to do and. I have x is greater than negative 1. So I am going to graph that on this number line. X is greater than negative 1. So here's my 0. I start at negative 1. And I go up because it said greater than. And x is less than 3. So now I go less than. Because of the word and, My answer is only those two. What's both? My answer is only what's both. So I started at -1, and I went to +3. Okay, it looks like an ordered pair. It is not an ordered pair. What it's saying is that my answer is anything between -1 and +3. That's what it's saying. But when you've got an and, your answer typically looks like an ordered pair. Okay? I want you to get started on this one. Okay. We are doing exactly the same thing, except now we have to solve. Okay, so take a few seconds and start solving those for me. Okay. You are going to solve both of them. Okay. I hope you got x is greater than -2 and x is less than 1. Okay, I hope that's what you got. Okay, we just solved those, just like we solved equations. Now, these are being combined by the word and. So I'm going to graph this. Okay, so I've got x is greater than -2. Then I've got x is less than 1. Okay, so again, we are looking at just this for my answer. And you want to graph it because then your interval notation is in the right order. If you don't graph it, sometimes students put the interval notation in the wrong order. So for this, they would put 1, -2 instead of -2, 1. And the reason that we can't do -2 or 1, -2 is it's not in the correct order. You always move from left to right, and you always have your lower value first. Yes?
On the homework, did you make the arrow go all the way across the graph or just in the middle is fine?
Just the middle is fine. Yeah, you can just post a solution.
Can we not flip the sign?
That is a great question. Okay, the question is, why do we not flip the sign? Why do we not flip the sign? The rule is we flip the sign when we divide both sides by a negative. Okay? What am I dividing both sides by? +3. The fact that this is negative doesn't do anything with the sign. That is a very common mistake, and that is an excellent question. Okay. Now I want to show you what something, another way that you can see ands. Okay? This is just another way that you can see an and. So anytime it's written like this, it absolutely is an and. There is no or. It has to be an and. And what you want to do is you want to think about this as having 3 sides. So most of the time, we have 2 sides to an equation or an inequality. Okay? In this situation, we have 3. And we are going to isolate the variable in the middle. Now, what's the first number that we want to get rid of in the middle? We've got 3x plus 7 in the middle. What do I want to get rid of?
7.
Good. So I'm going to say -7, and I'm going to do it in all 3 areas. Okay, you do it in all 3 areas. So I have -10 is less than 3x is less than 0. Okay? What do I need to do in the middle? Divide by 3. So I'm going to divide by 3 in all areas. So I have -10 thirds is less than x is less than 0. So negative 10/3, there's my 0 right there. Negative 10/3 is a little less than 3, negative 3. Okay, so here's where negative 10/3 is. And I'm going to 0. So that's my answer right there. Okay? And I have one more to do and just enough time to do it. Okay? You're not going to see this a lot, but I just want you to be exposed to it. Okay, now let's do an OR. Let's do an OR. Okay? Solve, graph, and write your answer in interval notation. Okay? This is an OR. We were doing ands, but this is an OR. So the first thing I'm going to do is I'm going to solve both inequalities. And we know how to do that. Okay, for our first one, we're going to add 5 to both sides. I'm going to have 2x is less than negative 6. Divide by 2. So then I have x is less than negative 3. Again, I don't reverse the sign there because what am I dividing both sides by? Positive 2. Okay? Here, I'm subtracting 1 from both sides. I have 5x is greater than or equal to 5. Divide both sides by 5. And I get x is greater than or equal to 1. Now, we are using OR. This is an OR, so you got to be careful. X is less than negative 3. Okay? Here's negative 3. And I go to negative infinity. Okay? Then I've got x is greater than or equal to. So what do I need right here? Don't forget that bracket because it's or equal to. That's why we have the bracket. Okay. So then I have negative infinity to negative 3. What do I use for or? Union. Don't forget that bracket again. Okay. Okay. I will be doing a help session on inequalities in this room at 11. Come if you can. If you can't, I'll record it. Have a good day, everybody.